In a previous video, we learned about empirical formulas. So this time we're going to learn about molecular formulas, which are related to them. In fact, a molecular formula is a multiple of an empirical formula. So let's say, for example, we've got one carbon, one hydrogen bonded together. This is an empirical formula. We're going to find, and I'll teach you how to do this in a little while, we're going to find a multiplier to run through this empirical formula, and so our molecular formula would end up being C6H6. So you can see that this is just a multiple. If your multiplier was 6, you'd end up with 6 of each. Over here we have a molecule of glucose. It's a sugar, C6H12O6. If we found a multiplier of 2, then our formula ends up looking something like C12H24O12. Each one of these subscripts is going to be times 2. Whoops, didn't want that. Let's go to a regular pen. So we end up with times 2 for each one of those. Multiply through, I had to get rid of my little smiley face. There we go. Okay, you go times 2 for each one of those, and you end up with double of the amount of each atom. So if you found the empirical formula and then through experimentation found the molecular mass, it's also called formula mass of the compound, you could find that multiplier by dividing the formula mass by the empirical formula. Okay, that's an awful lot of words for this formula right here in this tan box. This is what you really are going to need to solve with these. Finally, you're going to use that multiplier to determine the molecular formula. And I've got an example here. I'm going to show you how that works. So our first example, I've got a nice word problem here. Everybody loves those. This is very typical of what you're going to find in an assignment or quiz, whatever, what have you. So using the empirical formula for CH3O and having experimentally found the formula mass of 96.9 atomic mass units for a compound has the same elements, carbon, hydrogen, oxygen, you need to find the molecular formula. So first thing we're going to need to do is find that multiplier using this formula that we had on the last page. Okay, formula mass. In your word problem, this will always be given to you because it had to be found experimentally, and you're doing theoretical, you're doing paperwork, calculations, so this has to be given to you. 96.9 atomic mass units. You could end up, units could be grams, they could be grams per mole. So anyway, it's going to go on the top. On the bottom is the empirical mass. Okay, we don't have this, but what we do have is an empirical formula, and we can certainly figure out how much this molecule weighs in this empirical formula. The mass of one carbon, let me scroll down here a little bit. Okay, if we were to take the mass of one carbon, right there, there's a carbon, 12.011. This is right off the periodic table. The mass of a hydrogen, and we have 3 of them in our formula up here, so I'm going to go times 3. And I'm going to add that to the mass of an oxygen right off the periodic table. So I add all of these together, and that looks like it comes, let's see, 12, 15, plus it's about 31 or so. Anyway, 96.9 divided by, we'll say, 31, maybe 32. You come up with about 3. This should come out very close to a whole number. Don't round these under here when you're the atomic masses, but feel free, if this came out 31.1, 31.2, round it off to 3, because you want a nice whole number, a nice whole multiplier. Next, you're going to use that multiplier to find the molecular formula. So here's our multiplier, 3, but just found it right here, that 3 goes in front of the empirical formula from our word problem, CH3O, and you're going to multiply it through. And it gives us 3 carbons, gives us 3 times 3, gives us 9 hydrogens, and finally 3 oxygens. And that gives us our molecular formula. Okay, just to make sure that I have mentioned this, remember that numerically, formula mass is equal to molar mass. The units are different. As I mentioned up here before, we have atomic mass units. We could have grams, we get grams per mole. Numerically, those are the same thing. All right, so after watching this, you should be able to do this yourself. So here's one for you to try. We're given a formula mass, 283.89 grams, and here's your empirical formula. So go ahead and take a minute, find out how much this weighs, and then divide your formula mass by the empirical mass. And then when you're ready to restart the video, go ahead and I'm just going to click on this box right here. Your answer should be P4O10. Remember, your mass for this thing comes from the periodic table. So if that one was easy, let's try one harder. One last one and we'll end this video. Okay, so this one's a little trickier. You're given percentages. Here's your formula mass. Like I said, that had to be given to you. And you've got to divide it by how much your empirical mass is. Well, you don't have an empirical formula yet. You're given percentages. So you have to find the empirical formula first. And if you remember from previous videos how to do that, you'll be just fine. These percentages add up to 100%, so we can just assume that we have 100 grams. So let's go, we're going to go percent to gram, and then gram to mole for each one of these elements that are in this compound. And from the moles, it'll give you the number of atoms, and then you'll be able to write down what your empirical formula is right here. And once you have your empirical formula, you can find out how much it weighs using masses from the periodic table, and you can just divide this 166.3 divided by how much your empirical formula weighs. And I'm about to uncover the answer, so if you want to pause the video and try it yourself, you should. And when you're done, you should get K2CO4. Okay, I hope that helps you understand this a little better, and see you in the next video.